Well, hello everybody. Let's get into our first part of systems of linear equations. We're going to talk about three quick things. They're all very related here in this first video. We're going to talk about what a system is. We're going to talk about what a solution is. And then we're going to talk about how to check if a point is a solution or not, because that's one of the first things you're going to see. It's going to give you a system and you're going to have a coordinate and it's going to say, hey, is this a solution or not? So first thing first, a system of equations is basically two equations that are tied together. They work together to describe some sort of situation. We'll get more into that in the future, but for right now, you're going to see two equations like that. They may or may not have that fancy little French bracket or not. I mean, maybe it's there, maybe it's not. It doesn't matter. They're tied together, they work together, and so they're going to be on the same exact graph, right? And what a solution is it's a value that makes both equations true. So if it fails for one, no dice, right? So it's got to be both, and they've got to make them true. And so what that would mean, for example, we're going to see, I'll show you right now that this is a solution to that. This right here, this is a solution to that equation right here. However, watch, let's see. But this one right here is not. This is a solution, and this is not. So that ties us into this next one right here. But before we get there, a solution is a value that makes the statements true, but also when you graph it, where the two lines cross, well, that's where the solution would be. So for example, if we had something that looked like this right here, so this would be one equation, this would be our other equation, where they cross right there, that is your solution, right? So eventually we're going to learn three different ways to find solutions, but that's what we're doing right there. We're trying to figure out where do they cross. Sometimes you can do that by graphing, sometimes not. Sometimes you have to do it algebraically, but here's how you check, okay? So we're going to see this is a solution and this one's not. So this will be true for both. This won't be true for both. Doesn't matter. If it works for only one, no go, not a solution. So this is y, this is x, this is y. Let's do it, right? So y, right, equals 4 times x plus 3. Parentheses always help. Let's check one. Don't need to check them both at the same time. Let's check one. If it works, we'll move on to the next one, right? So -1 equals -4 plus 3. At this point, I can say that's obviously true. -4 plus 3 is -1. We're going to say good. Now let's go ahead and check this x and this y for the second equation. So -1 equals negative of -1. And this is exactly right here why you use those parentheses, because that's going to keep you from getting into too much trouble, right? The parentheses preserve the order of operations. So now we have minus a negative, which is plus, right? So that's true also. -1 is 1 minus 2. This coordinate made both equations true. Both of these equations are true at -1 for x and -1 for y. This is a solution. Now, this one will not be a solution. Let me show you. If it doesn't work for either one, it doesn't matter. So let's plug it into one, see if it works. If it does, we'll plug it into the other. So here's what we got. So we've got y, which is 11, right, equals 11 equals 4 times 2 plus 3. So that's 11 equals 8 plus 3. Well, that's true. 11 plus 8 is 3. So it works for that one. So now let's go ahead and check the other one. So we've got y, which is 11, right? -2 minus 2. Well, this one's not true. -2 minus 2 is -4. That's not a true statement at all. So this one right here is no, not a solution. That one is, yes, a solution. So to check if something's a solution, you plug in your values to one equation, and you simplify it. If it works, try it on the other. If they both work, yes, it's a solution. If it only works for one or it doesn't work for either one, the answer is no. Now, one last thing. If we started with this right here and we found out it didn't work, there's no need to even try the other one. It doesn't matter. It's only a solution if that point is on both lines. If that point works for both equations, it's a solution. Otherwise, no dice.